So continuing with yesterday's video, class 11. So what we learned in yesterday's video is the resultant, or rather the magnitude of the resultant, is given by magnitude of a squared plus magnitude of b squared plus 2ab plus 2 magnitude of a into magnitude of b cos theta, to be more precise, okay, where theta is the angle between vector a and vector b. Okay, so this gives us the magnitude of the resultant vector, and this equation tan phi is magnitude of b or modulus of b sine theta divided by magnitude of a plus magnitude of b cos theta. This is the equation that is used to find the direction. This is direction with respect to vector a, of course, with respect to vector a, don't forget. Alright, now since we are so lazy to, we don't want to go on writing the modulus sign every time and the arrowhead every time. So whenever we are talking about only the magnitude part of the vector, remember, so we simply write r is square root of a squared plus b squared plus 2ab cos theta, remember that. Okay, so since we are only talking about the magnitude part of the resultant vector, so therefore we write this. Okay, that is only because we are being lazy. Alright. Likewise, tan phi is b sine theta divided by a plus b cos theta. So whenever you see only this way of specifying a vector, you have to understand that we are only talking about the magnitude part of the vector. Get this thing drilled inside your head, remember. Okay, alright. So with this, let us continue. I want to show you one simple problem in this video, which goes like this. Two forces having magnitudes 5 Newton and 10 Newton are inclined at an angle of 60 degrees with respect to each other. Find the magnitude and direction of the resultant vector. Alright, a resultant vector, rather the resultant force, since the question speaks about two forces. One is that of magnitude 5 Newton and the other is that of magnitude 10 Newton. So say for example, so what we take is, this is vector A, so we are giving the forces names. Okay, so this is, we are calling this force A, vector A, or force A, and this is force B, or vector B. So this is our vector A and this is our vector B, and we are saying they are inclined at an angle of 60 degrees. So theta is 60 degrees. So magnitude of vector A, that is modulus of vector A, is 5 Newton, as you can see. This is exactly what I've written, and modulus of vector B is 10 Newtons. So we know their magnitudes, and we suppose that since they are inclined at an angle of 60 degrees, that is what the question says. So therefore the picture is something like this. Alright, actually my picture is not very precise, because remember, the length of the vector gives us an idea about the magnitude of the vector. So therefore, since vector A is half the magnitude of vector B, so therefore this vector should have been almost half of this size, this length. Okay, my picture is not very precise, you all draw that for itself. Okay, so for example, this is my vector A, so double of that would be vector B. So it should be something like this. Alright, this is a vector A of magnitude 5 Newton, and this is my vector B of magnitude 10 Newtons, almost half. Okay, so to get the resultant, what we do is we first of all complete our parallelogram. You have to complete the parallelogram, don't forget. Without completing the parallelogram, do not draw this diagonal without completing the parallelogram. Why I say this? Because I have seen this many a times. Okay, your seniors have drawn, many of your seniors have drawn diagonals without drawing completing the parallelogram. So complete the parallelogram first, only then draw the diagonal, remember. So the picture should have been something like this. Okay, so since we have to calculate, the question says calculate the magnitude and direction of the resultant vector. So therefore, to calculate the magnitude, we know modulus of r is this. Okay, this is the equation. So r is, then simply substitute the values given. Magnitude of a is 5, so 5 squared. So magnitude of b is 10, so 10 squared, plus 2 into magnitude of a 5, magnitude of b 10, and theta is 60 degrees, so cos of 60 degrees. Simply substituting the values, remember. So r is what? Modulus of r is what? So 25 plus 100 plus 2 into 5 into 10 into cos 60 is half. You should know these values. Okay, so simplifying, what we get is square root of 175 Now square root of 175, you are free to use a calculator. Okay, you have to use the scientific calculators. So modulus of R is 13.23 Newton. So this is the magnitude of the resultant vector, remember that. Okay, so although I write vector A plus B over here, so this does not mean the resultant is 10 plus 5. This is only the notation for the resultant vector. So I can write modulus of vector A plus B, whole modulus of vector A plus B is a new vector, remember. So modulus of vector A plus B is 13.23 Newton. So magnitude of vector A plus B is 13.23 Newton. Okay, so this is the resultant, remember. Now direction. So what we are supposing is, we are supposing this angle is phi. You have to show your angle phi in the picture. Don't forget. So you can consider either this to be phi. You can also consider, if you don't want this, if you don't like your phi being this angle, you can consider this also to be a phi. But there will be some changes in your equation for direction. That is, there will be some changes in this equation. Okay, now since I don't want to confuse you all, okay, if we were discussing this in a proper classroom, okay, I would have shown you that. But since I'm teaching you virtually through this video, okay, so I don't want to confuse you all. So stick to this, and always consider your angle phi to be this angle, remember, not the upper one, not this angle, the angle which the resultant makes with vector B. Always consider the horizontal vector to be your vector A. Always consider the other vector to be a vector B. Okay, and always consider the angle which the resultant makes with your vector A to be phi. Stick to this. Alright, otherwise you will start having problems. Okay, so stick to this for now. So I have shown in my picture, but you have to show, remember, what your angle phi is. Okay, in the picture you have to show. So I have shown my phi over here, angle phi, that is the angle which the resultant makes with our vector A. So tan phi we know is this b sine theta divided by a plus b cos theta. So I have gotten lazy over here. Okay, so I'm not showing the modulus sign and the vector notation. Okay, arrowheads. So I'm straight away writing this. So b is 10. Theta is sine 60, theta is 60 degrees. So divided by A, that is 5, plus B is 10, cos 60 degrees. Then you simply substitute the values. Sine 60 is root 3 by 2, cos 60 is half. Okay. And be careful over here. Be careful over here. This does not mean that you first add 10 plus 5, 15. 15 into, it's not 15 into half, of course. Okay. First of all, you have to simplify this. Don't forget the board mass. Alright. So after simplifying, so tan phi is 5 root 3 divided by 10. Okay, so which is equal to 5 root 3 divided by 10. So 5 and 10, they divide each other. So you get tan phi is root 3 by 2. Okay, now this implies phi is tan inverse of root 3 by 2. In yesterday's video also I told you tan inverse, sine inverse, cos inverse, you have cot inverse, sec inverse also, are operators that operates on some number giving you an angle. Okay, if you have scientific calculators, you can try using this. Tan inverse, okay, you'll have this also to calculate tan inverse, sine inverse in your scientific calculator. So tan inverse of root 3 by 2 will give you some angle. Okay, now if you don't, just in case you don't have a scientific calculator, okay, you can stop over here. Phi is tan inverse of root 3 by 2. You can stop over here. Alright, just in case you don't, because you don't know how to in case you don't have a scientific calculator, you don't know how to calculate this. Alright, so therefore, if you don't have a scientific calculator, you stop over here. The angle is this much. Okay, but if you have your scientific calculator, you will see that tan inverse of root 3 by 2 will come out to be this 40.89 degrees. So what we get to see is the resultant has magnitude 13.23 newtons. Okay, so this length is 13.23 newtons. All right, and it is it is inclined at an angle of 40.89 degrees with respect to which vector? You don't forget to specify that. with respect to vector A. You have to specify it is inclined at an angle of whatever with respect to which vector. If you forget to specify after doing all of this work, you forget to specify this angle is with respect to which vector, you lose marks. Remember that. Okay, and this is therefore how you conclude. The magnitude of the resultant vector is 13.23 newtons and it is inclined at an angle of 40.89 degrees with respect to force of 5 Newton. Since the vectors that we are talking about in here are forces, okay, so therefore with respect to a force of 5 Newton. Now I forgot to give you a homework over here, so let me give you here. Let us consider, okay, let me give you something like this. I have a vector A having magnitude, how much? Having magnitude 2 newtons or 2 meters per second squared. Okay, so if the unit is meter per second squared, you have to tell me what vector we are talking about in here. Vector B is, for your convenience, let me give you 4 meter per second squared. Okay, and say for example they are inclined at an angle of how much? Sine cos. Okay, so they are inclined at an angle of 45 degrees, say for example. Theta is 45 degrees. The question is, find the resultant vector. Find the resultant vector, meaning find the magnitude. MAG means magnitude. Only for me, remember, write magnitude in full, you all. Find the magnitude and direction of the resultant vector. So this is your homework. Okay, so you have to check if you have a textbook. Okay, just in case you have a textbook, check in your textbook also different problems. All right, so the more numericals you practice, the more problems you practice, the better you get. Okay, so this is for the video. Thank you.